So we're going to be doing the density lab. We're going to be trying to find the density of different objects. For example, we're going to find the density of this object. We're going to find the density of a penny, the density of aluminum pellets, and the goal is to find the density of an unknown object. So this unknown object is what you're trying to identify at the end. So remember, density is an intensive property of matter, and it can tell us something about that matter. But we're gonna need to use mass and volume, which are extensive values, to be able to determine the density of the object. So we're gonna go ahead and start by finding the density of this object here. So this is a rectangular piece. Now to find the mass, we're gonna use a digital balance. So we have our digital balance here, and we're going to zero it before we actually put the item on there. So we're gonna go ahead and place it on here and write down the mass of this object. Okay, now that we've identified the mass of the object, we're gonna go ahead and determine the volume of this object. So since it is a rectangular piece, it's pretty large enough, we can actually find the volume by looking at the different sides of it. So we can multiply the height, the width, and the length of this object. So I'm gonna go ahead and measure it in centimeters. Okay, so we're gonna measure it in centimeters, and then we're gonna multiply those three to find our volume. Once you've determined the volume by looking at the three different sides and multiplying them together, then you're gonna divide the mass of the object by the volume, right? Once you've done that, then you're going to find the percent error. So you're gonna compare your number, your density, to the actual density of this block, which happens to be 0.541 grams per centimeter cubed. So to compare that, please use the formula accordingly and figure out what percent error you have based on your measurements and the actual measurement. We're gonna record the density of pennies now. Pennies are made up of mostly copper. There's other metals in there, but we're gonna go ahead and compare that to the density of copper itself to see how close it is. So we're gonna go ahead and place this on the balance to find the mass first. We're gonna use all 6 pennies so that we can see the displacement of water a little bit better. Now notice a penny is a cylindrical shape. We could probably use a ruler to look at the height and the radius of the circle and determine it, but it might be a little bit too difficult to do with a ruler. So we're gonna use a water displacement method to actually find the volume by noticing how much the water rises within the graduated cylinder. So let's find the mass first. I'm gonna go ahead and zero it first. Okay, the next step is we're gonna go ahead and take our 6 pennies. We're gonna add water. The amount really doesn't matter because we're trying to find out how much the water level rises. So we're gonna go ahead and add about 10 milliliters, and then we'll go ahead and record how much the water level rises from there. All right, so once you've determined the mass, the water displacement, which is the volume of the 6 pennies, then go ahead and find the density by dividing the mass and the volume, and then determine your percent error. You're gonna compare the penny density to that of copper, and then determine the error, okay? Maybe think about why you would have some error, and as I mentioned, that is not the only metal within a penny, okay? So when you look at those results, just consider what else could be in there. Okay, for the next experiment, we're actually going to find the density of pure aluminum pellets. So aluminum, metal. We're gonna go ahead and find the mass again, and then we're gonna do water displacement as well, since this is an irregularly shaped object. They're not all the same shape. So we want to see how much volume it takes up within water. So let's find the mass first. We're going to go ahead and zero the scale. All right, so we're going to go ahead and use water displacement. So we're going to use the graduated cylinder to submerge it. Again, the water amount does not matter. We're going to go ahead and fill it up to 5, and then we'll add the pellets in there and then record how much the water went up by. So that will be our volume, how much volume the aluminum takes up, or how much space it takes up in the cylinder. Okay, once you find the volume, you have the mass, go ahead and divide them, find the density, and again, determine your percent error. So you're gonna compare your density with that of actual aluminum by referencing the table and try to determine how much you were off by looking at that percent error. Okay, finally, we're gonna try to identify this unknown metal. So this is gonna be our unknown. So we're gonna go ahead and determine the mass of it and the volume, and then try to determine what density it has and compare that to a list of known metals and see if we can figure out which metal this is. So let's zero the balance and find our mass. So once you find the volume and you've got the mass, divide them, find the density, and try to compare it to other metals densities and see if you can determine what the unknown piece is. Good luck.